Cool. I guess it's a lunch time right now, but still, it is going to be a very, very interesting session. So we are going to talk about a famous AI, LLMs, right? We always use AI for multiple things. I hope I am, is my talk is, not too fast, right? It's absolutely okay, perfect. Cool. So we leverage the AI for everything, almost for day-to-day tasks as well. In organizations, we have integrated AI in every stage of our ecosystem, like applications, it can be a chatbot, it can be anything. What we are going to talk about is how do you do a shift left? What does that mean is security into the DevOps. That is what we are going to talk about. And the main talk is regarding the threat modeling. How do you do a threat modeling of the LLM applications? With that, I would like to go over the next slide. If I have the, yeah, perfect. Cool, this is a small agenda, although it is going to be a not practical, but yes, we are going to show how to conduct the threat modeling using the traceability metrics. And this is a small agenda we have. We are going to just cover a simple introduction, then followed by the threat modeling, what exactly it is, why it is required, and what is the significance of that. And then we will deep dive into the OWASP. How many of you know the OWASP? Anybody? Little bit? It's like a 30? Yeah. Okay. How many of you know SANS? S-A-N-S? No? Perfect. OWASP is one of the framework, or we can call it as a baseline, which talks about application security. It's not only limited to the web applications, it's also deal with the mobile, IoT, LLMs, Gen AI, and plenty of things. So we'll deep dive into that and how we have created an architecture diagram, which is a simple architecture diagram, which we will show you how the data flow happens and what are the different trust boundaries, and we can do a threat model on that. With that, I would like to introduce myself. So I am into security for more than 13 years now, mostly offensive, but defensive as well. And I would like to probably hand over to Pallavi just to introduce herself.
Hello everyone, this is Pallavi, a cloud security. Thank you. A cloud security manager by heart, but pen test at heart. Thank you.
Cool. So, okay. How many of you know about threat modeling? We know threats. We know model. But how many of you know about threat modeling? Anyone? Threat model. It's not a model which we talk about on the stage, right? This is the, okay, perfect. Yeah, I got the one hand. So threat modeling is the systematic approach to find out the loopholes. In a security talk term, we can call it as a threats. It is a potential threats, pinpointing the potential threats in the specific architecture or application or infrastructure. It is proactive approach, not a reactive. So it's basically happen before the design phase. So when we talk about SDLC, software development life cycle, testing, designing, planning, coding, everything. But this is something which comes when you have a design in place. When you actually architect the things, we start, the architect, the specific infrastructure ecosystem, data flows and everything, the threat modeling comes into picture during that design review process. So if you look at these circles, this is what is our end goal is. What are we exactly working on? That is what is your architecture and data flow. What can go wrong? That is what is your outcome. Outcome of threat model is something which tells you whether there are possible or potential threats into the application or infrastructure or not. What are we going to do about it? That is where is you need to work on the specific items which is threat modeling exercises has derived. So that might be vulnerabilities. Those will be potential. Why I'm calling potential? Because you're not actually testing it. You're not come to a conclusion whether those vulnerabilities are actually vulnerabilities or not. So those are the potential vulnerabilities. And the last one is the analysis. So did we do a good enough job so far? Is there any improvement is required? So this is something is a cycle we need to rotate always when we do a threat modeling. And have you heard about these frameworks? Anybody? Oh, that's, I'm seeing only these people are raising the hands, but it's a good thing. Stride, Dread, Pasta, and there are more. Stride is there is a full form for Stride as well. It talks about spoofing, tampering, repudiation, I for information disclosure, D for DOS, E for elevation of privilege. That is the privilege escalation. So Stride has a full form. So these are the frameworks or some of the standards which talks about threat model, which are used to conduct the threat model. But we are going to little bit shifting on the other side, and we will be talking about traceability matrix. Next. So now, significance. Why does it required? So we talk about reactive and proactive. And when we talk about reactive, is always you have the incident, you have the vulnerabilities found, it is exploited, and then we are tackling to fix it. When it comes to a proactive, this is what comes into the picture, because you are actually pinpointing the vulnerabilities into early stage of the development life cycle. And you see the risk identification is at the early stage. Then there is a proactive security measure. When you identify risk, of course, you need to know that these are the security measures which are lacking and which requires to be in place for you, so that you can just take care of it early life. Cost effectiveness, of course. Do you know why the cost effectiveness is there? Because if any damage happens, see, ultimately the vulnerability leads to there is some impact. We talk about business impact, we talk about reputational impact, we talk about financial impact, right? So these impacts are definitely very, very important to every organization. So the cost effectiveness, why? Because you are actually dealing with certain circumstances which may come if we don't do this. So that is going to take care by the threat modeling. And of course, compliance. So there are regulatory requirements, compliance requirements. They say that you should do a threat model. It's not a mandatory, but they tell that you should do a threat model. So just to adhere to, certify yourself with the compliance or regulatory requirements, this is what required. And of course, the adoption. So there is very, very, we have seen a lot of people or a lot of organizations have a problem with the adoption. When we say adoption, because why? There is no any, when we have an infra set, when we have different things set, we have certain things are into our comfort zone. So if you want to adopt anything, it takes a lot of time. So adaptability and scalability is much more important. Now, just a simple landscape. It's not going to be a deep dive. We have seen a lot of AI right now is booming in the market. We are leveraging a lot of GPT, Meta, and multiple stuff we have. So this just talks about the roadmap, how this evolved so far. Then you will see at this side, what are the models are available. Large language models are in market. And you can see how the GPT works and what are the workflows are. Now, this is what we were talking about, OWASP. So OWASP is the Open Web Application Security Project. Although it talks about web application, the full form, but it is not exactly only web application. It is also LLM as well. So they derive a top 10. What does top 10 means is the top 10 risks identified by the different organization. They come up with the statistics, they come up with the data, and they derive a ranking on the threads, and they derive this top 10. And you see, this is a 2025 top 10, and it is every time prompt injection is at the first place, because that is where your interaction happens directly to the LLMs. So you see, these are the top 10s, and we are going to deep dive into few of them, how to do a threat model for this kind of threats into the architecture and the data flow diagram. Now we are covering the business use case, the actual diagram. If you can just scroll up next. So we will see a simple diagram, simple architecture. As you can see in here, it's application. So when we talk about chatbot, it's just a simple example we have taken. There is a chatbot integrated into the application. We are taking example of the spend management or expense management system. So it's an expense support system which utilizes the chatbot, where user can interact to the application, and it has the AI assistant service, which then talks to the GenAI service and external or internal LLM models. It can be external, it can be internal as well. And you can see that vector database over here, that is an AI assistant database, which is trained data and everything is fine-tuned data is here. So this is what we are going to deep dive into. Now I would like to hand over to Pallavi, just talk about this entire architecture, and we will start with the threat model.
Okay, so why it's important to understand the components in this particular diagram? Can you just give that? Because in every layer, in every stage, there are threats. So where we can find out and which threats we can find out in particular, or what are the entry points. That's why we need to understand what are the components in this diagram. So if you see, the first one is host application. So this host application is basically our base application where the system has, it's integrated. So in our scenario, it is expense management application. And then the chatbot UI. Chatbot UI is something where the user enter their inputs or query, and then it reaches to AI assistant service. So what AI assistant service does is, it form a prompt, that is LLM prompt, using the user input or user query. It append some kind of instruction, information or statements to the user query and send that query or LLM prompt to LLM models. And if it required some user details or information which is stored in the database, it goes to the AI assistant database, which has all the user details, information regarding or expense information. And then it send that LLM prompt to LLM models through GenAI service. So GenAI service is something where it actually gives the user specific or human relatable output, or it gives the LLM model input which is understandable to the LLM models. So LLM models are the one, whether it is external or internal. So these models are basically trained with some data. So what kind of data it is? It is based on the application, based on the use case, based on the AI assistant database data. So it trained based on the use case, and it share the response with the best kind of quality response to user, and then it reaches to the chatbot and it shows the response to user. So this is how the workflow works. First, chatbot send the query to AI assistant. It asks the user detail to AI assistant database, or it view the details, and then it send back to LLM models. And then while LLM models send a response, it send the similar way like GenAI service and then AI assistant, and it send back to the chatbot. So this is how the components and workflow here. So LLM models. So there are different ways we can use LLM models. Like first one you can see here is third party. So third party is something where you can use OpenAI or ChatGPT, where you can directly, in your UI, you can directly utilize that particular using Colab or something like similar, and then you can utilize that particular third party. External marketplace is something where you can download that model in your, you can download that model and you can integrate, you can configure based on your use case. And then the next one or third one is internal one, where we have a base model which is Llama 3, or you can utilize any base model and integrate that base model with GPU server and train that data, and then based on your use case or business requirement, you can do your setup from the as an internal. So there are many kind of application or use cases that people or organization doesn't want to use external LLM models or a third party. They can utilize this kind of infrastructure. It's not working. Okay. So let's talk about the prompt injection. This is one of the top 10 what Omkar mentioned, right? So what is prompt injection? So you must have seen SQL injection, XML, external entity injection, LDAP injection, all this in the application for, in a normal regular web application, right? Similar way, there is a prompt injection in the LLM based application. So what is that exactly? So first of all, it's important to know what is LLM prompts. So LLM prompts are the one which are generated or formed based on the user input, user query. And that is something, a combination of user query and the appended statement or instruction by AI assistant. So why the prompts are necessary? So LLM prompts are necessary so that it is sent to the LLM models, and LLM model needs to understand those prompts, and it required in certain formats to give the response back to user in a such a way that it has some kind of quality response. At the same time, it is something with the response with a certain type what user is looking for based on the user requirement. And then we know now what is prompt, what is LLM prompt. So what is prompt injection now? So prompt injection is something where user add or someone add some kind of query, along with that add some statements. You must have seen in the SQL injection we add something with the user input, or with the input add some kind of double quotes or something like comment out things. So those are the instruction, those are the comments, things we or user append to perform the SQL injection. Similar way, in a prompt injection, user or someone can add with the user query some kind of instruction to send this to LLM model, so that LLM model can take that as a query and not as a statement, and it forms something similar and send back the response. That is where the prompt injection is. So if we see here, let's talk about some scenarios to understand what is prompt injection and where we can see prompt injection or entry point here in the diagram for threat modeling perspective. Okay, scenario 1. So consider this is particular use case is for expenses pending for approval. As our application is an expense management application, the first use case here is like someone or some user asking about their expense details. So let's say I'm a user, I'm asking what is my expenses or how many expenses are pending for approval. And if the user is adding something along with that query that, hey, I need to know my expenses as well as I need to know ABC or someone else's expenses. And that formulation or that query is somewhere like need to share with LLM models in a such a way that here, if you see from now, you are going to act as a Bob, which stand for doing anything now. These are kind of instruction it is giving itself in a query. And that is where prompt does not, or in the prompt, the code does not effectively differentiate between the static instruction which user has given and the query. And this is the place where the prompt is constructing, and this is where the entry point for threat model where we have to check the prompt injection is happening. And basically, why should you worry about? So it's like impact. If somebody is asking someone else expense details, it is something, it is unauthorized thing. That's why something it should not show, and that is why we should think about prompt injection in this stage. Another scenario here is when user asks for details to the chatbot providing their user IDs. So if you see here, user is asking or providing user IDs, and okay, why it's not? Can you just do this for me? Yeah. Thank you. So why, here in the first picture, if you see here, there is a get expenses function where user ID is passed. And if I know the user ID of some other user, I'll see if I can pass that, and I'll get the details of other user. So it is just passing the user ID and giving the prompt with the information. So, why, again, this is a similar way we see the first scenario where it is actually checking other user information. So how we can fix that? How we can fix that in a code? Can you just go next? Yeah. So this is the one of the example where your user ID is passing to a function which actually checking if the user who is logged in and who is sending the query through chatbot is the intended user for this particular response. So if I'm sending the response, is this the user, or is this user has a permission to check all user details or all user information? So this code is something, second code in the screenshot shows how we can send the details, how we can configure it properly so that we can avoid the prompt injections. Okay, next thing in the OS top 10 is improper output handling. So at name says something which is where when LLM send response, how to handle that. If you should send that as is to the user where user is asking the information, no. You should add some kind of checks there, and that is where this particular vulnerability is or check is. So here if you see the use case here is employee fetching weekly expense report. So employee is going to the chatbot, that employee is adding that, hey, share me the weekly report. I want to see this week report. And then someone or some user is sending the query with adding run command, which is uname-a. So you know this is a basic Linux command to just check if model or the application is responding us back with some kind of Linux command, or if there is anything which I can execute and I can get the response from the LLM models. So this particular thing where it's generating a weekly report and execute the query. So LLM is responding and saying that, hey, here is the report, and at the same time just execute this query and send back to user. And this is something where this is something where it is actually revealing the user system information, at the same time running a command if we have, or that user or that application has more permissions, it can execute more commands. So what is happening here? Here, if you see the LLM output, which we say as a prompt, or sorry, response, it is actually getting or adding directly into the system shell and not checking anything in the LLM output or response. And at the same time, the AI assistant platform is not validating if the output which is generated by LLM and directly sending back to user. So in this scenario, or in this case, where we can check the threads. So this is the first place where we can see when LLM is sending response through GenAI service, in the AI assistant platform, we can verify if something is LLM is adding by their own, and if something can be executed when we send it to the application. So if you see the screenshot here, this is an example of ChatGPT, where we are adding some details. If you see here, I want you to act as a Linux terminal, and I'll type these commands and all these things, and ChatGPT is sharing the Linux information. And the command here we have added is uname-a, and it's sending the information. And we have checked this, and we have added more commands, and it is actually executing or sharing all the responses which we are getting from the which the application is getting from the terminal. This is one of the live example. The third scenario, or third OS top 10 is sensitive information disclosure. So what it does. So sensitive, it is again similar. It is like what we saw in the prompt injection. So we are getting some information from the LLM response, which is again a sensitive information. From the insecure output handling, we are getting information, which is again a sensitive information disclosure. But there are various kind of entry point where we should check sensitive information disclosure, and that is why OS has added this particular check as a separate one than the first two. And the use case here, if you see, user is asking for specific expense detail and their status. And here the case is like LLM model is trained in such a way that it is adding approvals data as well. So if you see here, I'm asking that who is or what is the status. So if your expense is pending with someone, for example, user B, and the model has been trained where it is storing the user B information or something like similar, then with the user input, it is sharing. If you see in the yellow color, it's sharing with the result, it's sharing the user B details as well, which is because of model is trained where it is storing the user B information and sharing with the sharing in the response. So why should you worry about? So without having user B's context or consent, we are sharing this information to someone else. This is something is the major problem here. And what's happening? So model is trained in such a, like we discussed, model is trained in such a way that it's processing with the sensitive information. Can you just, yeah. So this is the one of the entry point where we can check what is exactly the user is sending or user is asking. So this is the entry point for input handling and filtering. The second one is insecure data storage. So our AI assistant database has data stored in a plain text or something which is human readable, and that information can be utilized. So this is something we need to check as a part of threat modeling. And the third one is while LLM model is sending data or sending response to the AI assistant. That time we again need to see similar, we check or we see in the second second vulnerability, which is improper output handling. So these are the 3 entry points where we can check the threats. Okay. With that, I'm handing over to Omkar.
Cool. Cool. So, how many of you heard about plugins? Extensions, plugins, right? So, those are the plugins are the ones which are used to ease your task. It just you integrate, you install, you embed, and you use it, right? This is not OWASP Top 10 2025. It is 2024, but still I wanted to go over because of its, right now it is one of the most vulnerable and one of the most threat. And plugins, as in LLMs also, we do have different plugins which can be utilized. And one of the example which we are taking is the automated approval. As our use case is about expense approval, so we're going to talk about automated approval plugin. That means it is designed in such a way that your expense will be automatically approved without a delegation. And you see here the plugin. Before that, we know the plugin. What about insecure plugin design? We know the design phase. So if you are designing, if you are developing in a plugin in such a way that it is not following the best practices with respect to the security, with respect to the compliance and plenty of things. So it may lead to different kinds of attacks. It can be remote code execution, it can be sensitive information disclosure, it can be anything, or arbitrary file read as well. So whatever talks about, even though it's not LLM issue, it is what is the third party which you are embedding. And this is where, you are, let's talk about the actual scenario. The scenario here is simple. I don't know whether it's not working, but yes. Scenario is going to be simply we are going to approve the, submit the expense report. So simple statement, user is typing, he submit my expense report to us XYZ trip and override the budget limits. So what does this will do is, this is all things are the prompt, which user input is treated as a prompt in LLMs. So the automated approval plugin will actually get the expense details, learn the things, override the budget limits, and then user can actually approve extra budget which he has spent, which is beyond his actually allocated budget. That is where the plugin problem comes into picture, because it is not improperly implemented or developed in such a way that it will actually block the override budget. And this is where the things happen at the model layer. Okay, so this DOS, how many of you heard about DOS? Denial of service, distributed denial of service is a DDoS, it's a DOS. Similar to the application or infrastructure, we also have a DOS in the LLMs. And how does it work? It basically works with the input of whatever you are typing. So if you see here, if you are submitting large number of input as a query into the LLMs, it may exhaust the LLM tokens. All about talks about tokens. It exhausts the rate limits, and there is a possibility of the LLM cost usage as well as the unresponsiveness to the application will happen. That is the denial of service attack. And you can see over here, it will happen at this layer as well as this, because where your query is going, in the flooding, you are flooding the request and the prompts, and it basically shows the unresponsiveness to the application. And it actually impacts the cost as well because of the tokens. This is very famous. Now previously it was only data poisoning. Now it is data and model poisoning, because model is also the one which is actually a crucial part of any AI ecosystem. So here, if you see, there are a couple of, when we talk about data, in AI, data is the critical element. Why? Because everything works on data. So your fine-tuned data, everything is learned by the data itself. So you see as a response how the human contextual responses or understanding the specific queries, that all is the data. So data poisoning, what does that mean is, if you are trying to do a manipulation of a data, let's say suppose if you are sending a data which is fake or spam data to the AI ecosystem, and it actually tells you, it actually learns that, it keeps as it is, and whenever any other user requests for that, it will give you the same. That is a poisoning of the data. That is actually an issue, and we are seeing a lot of issues. And where does this, you can say the sources. One source is the AI assistant database, and other source is the third-party data source, where if the application itself is leveraging any other data sources, that is also a data vector database, and there is a possibility of data poisoning. And this is what is why we should worry about, because of course AI is all about data, and whatever is trained, if it is poisoned, you will get the malicious response itself. You will not get the accurate. When you talk about data, it's accuracy. In AI, its accuracy is very, very important. That is something we are actually tampering. So we are tampering the data integrity over here. So now, I believe it's okay. So this is where you see as a, it's not working. Okay, where it occurs, the model poison also, where this occurs in the base model as well as the custom model. It's where the model will poison, and then now we will shift towards the next one is supply chain. Simply, now most of the organizations are doing a supply chains. I always give an example of supply chain as one to many. Why? Because if you take over one, you will get all others as a free. Because it's you are actually doing a relation with the one to many others. Let's take a simple example of, have you heard about SolarWinds breach? It's a security breach, biggest security breach happened with the simple, it was a supply chain attack, it's a simple package. And it leads to a breach of entire huge organization and their vendors. So that is a supply chain. So that is where we are talking about how it can happen. We are here, it's only the training data, ML models, and deployment platforms. So these are the three critical areas where the supply chain attack may occur. And how does this work is simple. If you are creating a simple hidden malicious package, which simple package you have, as we have discussed about plugin. So you have created with the malicious instruction, and that is getting integrated into your LLM ecosystem. There is a possibility of you can do a multiple things. That package can leverage, derive the instructions, and send back to the attacker. So this is where the supply chain attack can occur. And of course, why you should worry out, because this is where you are talking about malicious backdoors. Because that is it's a simple, or I would say straightforward naming convention is a backdoor. Because that is the plugin and the package is malicious. And with that, you have seen this is what is the exact, we haven't covered entire things because with the interest of time, but still, you see over here where to look for potential threats. So at every stage of the architecture on data flow, you will see this is where you can see for input handling, this is where you can see for prompt injection, this is where you can see for data storage. So in secure data storage, as we mentioned about plain text, even though we are storing a data in plain text format, it should be sanitized before you are getting a response. It should be filtered out properly. Model DOS over here, where the request goes to the models and they leverage the tokens. And these are the areas. Now with that, as I mentioned before, the traceability matrix. Why does it important? We have different frameworks which we discuss about Stride, Red, Pasta, and multiple others, right? OWASP as well. But traceability matrix is actually talks about different factors. One is the vulnerability, what exactly is the threat is. One is the threat agents. Who is the actual attacker, or who is the user who is actually with the malicious intent. Another one is the attack vector. Attack vector is what thing you are using. That is the actual attack vector. Surface is where it is occurring. How is means what is the attack method you are leveraging, whether it is a prompt injection, whether it is any other things. What is the impact? When you talk about impact, have you heard about CVSS, Common Vulnerability Scoring System, right? It's 4.1 is also there. So CVSS talks about different factors or parameters. And we derive the CVSS score based on the impact and based on certain parameters. So the impact is all about that. Likelihood is how easy to exploit this vulnerability. That is the likelihood. Whether it is easy to exploit or it is very difficult, it is complex, chaining of attacks required, exploit writing is required. So it's likelihood. And the mitigation is the controls. What are the controls? That is where the circle we discuss, right? What are you doing about it? And did we do a good enough job? Those two things will be a controls or mitigation strategies. So as you can see the traceability matrix, and this is what actually the outcome going to be. It is for every stage of the threat model exercises, we can derive this not only after the entire thing, but yes, we have just draw entire metrics just to showcase how the things works, how it can be derived. And now, simple, if we talk about patterns and trends, it's nothing but it's just a small. How many of you heard about DeepSeek? Are you using that? That's a good thing. That's a really bad thing. As a security, we are in a security. It can be offensive, it can be defensive, it can be anything. So DeepSeek recently, not recently, but a few months back, if you have heard about, it got entirely compromised. And still people are leveraging it. That is a question as well. So you see over here, it was a Wiz research. So Wiz is one of the company who did the research, and they were able to exfiltrate almost multiple things with the database, log stream, API leakage, even though the AWS secret key, and they were able to get a hold of their environments. So be mindful before using any kind of such AI engines which are available. We need to thoroughly thoughtful about it and do a research, and then we start leveraging it. How many of you have heard this? There is one of the famous article. So you can use or leverage AI to automate the exploitation. If you provide a CVE ID, you can just automate and it will exploit. So this was the very big research happened. So you just tell the instruction, hey, how hack this website using this blah blah blah. It will just check the tools. It will check the CVEs, it will do the things, it will successfully attack and exploit the environment. And this was the biggest research, and still it is working. So they can anonymously or atomously exploit zero-day vulnerabilities. That is, you can also try it out. And with that, I have the last slide with of course, the best practices and key takeaways. Actually, the best practices when you talk about, it's a very huge thing, but still we wanted to keep it crisp and clear. And you see threat modeling, why it is required, because you are pinpointing the threats in early stage of life cycle. The next thing is if you talk about systematic frameworks. So frameworks is, so when we do a threat model, when we do security team works, it's basically not a single, it's a shared responsibility. So cross-team efforts are always required. Data flows, you have to focus on. how the data is flowing, how the data is storing, data in transit, data at rest, everything we need to focus on and how the things are in place. Risk-based approach we have to do, as we say in the traceability matrix. Mitigation strategies, and this is something very good word, biasness. Have you heard about hallucination, biasness? Those things, AI is now doing that. That's where we need to more focus on the biasness, privacy of the data, privacy of the information. Misinformation is what we talk about poison data. With that, I believe the stage is open for the questions. Thank you very much.
Thank you very much. Для
I'm
зрителей...
sorry, I have questions.
Можешь, пожалуйста, секундочку подождать? Я общую информацию скажу,
Can you
что...
please wait a second? Because I want to say that you can actually ask your question in Russian, because we do have simultaneous interpretation provided. If you want to ask your question in English, that's even better.
Так, вопросы зала.
So your question, sir.
So, good day. My name is Oleg Burnaev. I'm independent researcher too in my free time, and I have two questions for you.
Okay, perfect. Yep.
Yeah. My first question is, how do you think, what difference between prompt injections and jailbreaking?
That's a good question. Next question. Yeah, I'm going to answer that. Yeah. But next question, yes. Both the question I can answer it quickly. Yeah. So prompt injection and jailbreaking. If I talk about it, is no difference. So it's a type of injection. It's an indirect injection. So jailbreaking talks about indirect. Prompt injection can be a type of two, both. So the type, jailbreaking is a type of a prompt injection.
Okay. And my second question is, how do you think, how we can classify a case of model drift due to your report?
Model drift due to?
Model drift due to your report of ASP top 10 for LLM and so on.
Slight, I didn't get to the question. Model drift due to?
Model drifting. Yeah, how to you can classify this?
Model drift?
Model drift, yeah.
So
If you use the OWASP classification.
Model drift. With respect to OWASP you're talking?
Yeah?
So yeah, so drift, so model drift when you talk about, it's basically how your models are being built. So there are certain ecosystem in the model, right? So when we say a model drift, it is how the models are being trained, how the models are being hosted and everything. So the drift is where, you know, the integrity and the availability. So the integrity where the models we talk about, that is something which I believe we should probably do some kind of checks using the, I don't know, maybe the matching of the specific checksums and all that stuff. That is the integrity where the model can be poisoned or model can be tampered. So that can be one technique that can be leveraged.
Okay, thank you.
Thank you.
A second question in this side.
Yeah, hello. Yeah. Thank you for interesting presentation.
Thank you.
Could you, what will you advise to use to filter user input and filter LLM answer?
Okay. So filtering, simple, I will give you example. You have a simple application. You type input. So input, so let's say suppose there is a first name is a desired input. And if you are typing a simple different JavaScript or any kind of unintentional input, that becomes a model or not model, but the application should first understand, is this input is actually which is desired we are asking? It is not. So the filtering, we can say a sanitization library. It can be anything HTML encoding or anything. So sanitization library you can place in the middleware and the input is coming, it should first check whether it is adhering with the what the context is all about. The context means first name, for example. And when output, so let's say suppose if you're trying to share the, get the expense or get the information of the XYZ, and it is revealing the sensitive information of a user, like maybe it can be a driver license or something like that. So while sending a response, it should check, there is a application have a concept of output encoding, if you heard about. So like that, we can have the sanitization in place for the output as well, where it should check the parameters if the sensitive information is getting passed, and then it will filter it out, redact, or maybe we can call it as a redaction. That can be done and that can be passed. So that is where, this is what need to be done at the application as well as the model layer, because models also train on the data which we have, and the data itself is containing the sensitive data. It is going to be disclosed as well.
Yeah, thanks for answering. Not the hard way is check the proper use, but the hard way is to check if there some private information you're saying, right. So you suggest a sanitizing library is good thing for
Correct.
this.
So there is a famous concept of data security. It talks about data classification. This is where comes into picture how you need to classify the data, what kind of data you have. It can be PII, it can be PCI, it can be multiple. So the classification is the process where it actually tells this is the data which is falling under PII, it should be sanitized, it should be scrubbed, it should be redacted. That is the one approach.
Yeah, thank you.
I have one question. It's me.
Oh.
Hello. No, I'm here.
Sorry.
No.
I'm just,
I
but
have
yeah.
a question to Pallavi Jamshu. You told about prompt injection a lot, and it's interesting. How do you think? Which of attacks you present is quietly used only for LLM without other web applications? For example, DOS, it's a simple attack for every web application. The same is injection, but we tell not about SQL injection, we tell about prompt injection. But what is the specific of LLM attacks?
Okay, so if it's specific to LLM application, yeah, prompt injection is one of the thing, but it's similar like your SQL injection, LDAP injection. But that is specific to LLM, because prompt something which user is entering and it is getting a response on the similar way. So it is not exactly similar in the another or what we can say a generic web application. Apart from that, I would say one of the only specific to LLM application is data training and the poisoning, model poisoning attack. And at the same time, supply chain attack, those are only specific to LLM right now. Yeah, they have a web application as well, but specific to LLM, there is, I think, only data model poisoning. Apart from that, all are present in the web application, right?
So
improper output handling is again part of web application, but the ways are different to find out this thing or in the LLM application. But if you ask specific about LLM, then I would say model poisoning, because it is something where model comes into picture, training the data and how we utilize that data in such a way that we get some kind of information. See, impact is same, right? You get the information, sensitive information, you get something which is not desirable output, but the way of performing attacks is different. Anything else?
Thank you. And continue my question. There are many vendors present in our practical conference, and it would be interesting to know what trends in the development of LLM protection tools do you see in Indian market or in all the world?
Okay. So, okay, if you talk about what are the things which we can do in terms of safety, you can say, right? So, guardrail is one of the things which we are basically famous for utilizing or securing the LLM or a layer in the LLM security. So, along with all other controls, there is a guardrail which actually secure or which actually help to prevent this kind of attack. Not 100%, but yes.
So take an example of firewall. So guardrail is nothing but a firewall for the LLMs. Basically what they do is, we talk about biasness, toxicity, PII, disclosure, abusive language, sexual language. So multiple things, it actually has the regular expression and the patterns. So guardrails is, you can say, a firewall in between the input and output. So they have two things, input guard and output guard, which takes care of these things. So although the while coding itself needed to take care of it, that's the first area. But when we talk about defense in depth approach, guardrail will help as a firewall. So guardrails, if you just search it out on Google or anywhere, just search it guardrails, you will get the things. There are a lot many guardrails, and there is one of the famous guardrails AI hub. It has multiple validators which talks about these firewalls.
And that is open source.
Okay, thank you. So now we have several questions from the audience, please.
Да, здравствуйте, спасибо большое за доклад.
Yes, hello. Thank you very much for your presentation. And my question is very simple. Can you please repeat your question? I haven't even started my question. So thank you very much for your presentation. The question is very simple. I read articles about hijacking LLMs or stealing LLM weights. Is that really possible? And what could be the scenarios there? Thank you.
Perfect. You asked about hijacking or stealing, right? So yes, there is a possibility. Simple example, we have a marketplace. We have talked about Hugging Place, right? So I will give you an example in parallel to the hijacking of the mobile applications. Simple, right? So you do a reverse engineering and you do package your own malicious payload into the application, and then you rebuild it and you upload it to the store. Similar to the marketplace or in the LLMs. So hijacking is possible. You just need to reverse and manipulate the instructions the models has, and then you can upload it. Of course, there is a lot of integrity checks, multiple checks are there while doing that, but yes, there is a possibility of hijacking the LLM model itself, and that can be leveraged, which leads to a supply chain attack as well. So yes, that is I would not say it's happening continuously, but yes, there are attacks we have seen in the we can say as a hijacking or poisoning. Yes.
Да, спасибо.
Thank you. What about stealing weights? Next question.
Hi, my name is Artem Semyonov, and I work as Artem Semyonov. In the last few slides, you talk about agents, LLM engines. What do you think about the threat landscape associated with the use of agents in application, in simple web application with agents? Do you know of any incidents with LLM agents? Это мой вопрос.
And that was my question.
You're asking about LLM agents? Like, is there anything in the market or something, or how is it?
Integrating in web application.
Okay, yes. So, have you heard about software as a service, SaaS? There are a couple of companies, SaaS, we talk about SaaS. What does that mean is, they offer you a software, like they develop a software and they offer you to use it. That is a software as a service. They also deriving right now the SaaS LLM agents. What does that mean is, the agents are leveraged to do a certain tasks which are application as, and that is actually integrated in the application. You can say using a chatbot, or you can say using the into the application at the API level, or it is calling the API itself. So the agents are SaaS agents. We take an example of SaaS, software as a service agents, for using AI.
Экземплы привести? Подождите.
Would you like to give us an example?
Any practical examples, historical from the real companies, when they report that it was really attack on LLM agents? Do you know something cases?
Yeah, so there was an attack happened on the LLM agents. I don't know exactly the organization name, but it was through the agents, how the agents were trained, how the agents were leveraged into the ecosystem of the application, and using that, yeah, there was an attack happened, but I don't exactly recall that.
Here's the attack. LLM agents cannot.
Yeah, oh, this one, right? This is the one, yes. So this is where, this is what we are talking about. It's a CV agent, and this is something you can also try to leverage to exploit a specific CV if that actually environment, the target environment is vulnerable for that. So this can be done, yes.
Okay.
Thank you. Next question from the right side.
Hello, my name is Diana. Thank you very much for presentation.
Thank you.
But question will in Russian because I'm not sure that I can explain correctly.
Yeah.
Все знают, что
It's a well-known fact
почему
that sometimes you cannot really understand why an LLM provides a particular response, how it makes its decisions. So my question is like this: can we actually learn that with the help of reverse engineering? Thank you.
инжиниринга, изучая,
Can we use reverse engineering
узнать, как
to
именно она принимает
study the code of LLM to learn how it makes decisions?
Okay. Yeah. So the question is all about, can we study the responses or how the training is done, and you can do a reverse engineering, and then you can, based on that, you can train it. So it's kind of, you're trying to reverse engineer the LLM, and you see whether the questions are which are being asked, that is accurately responding back. Is it like that? Okay. So reverse engineering is, yes, possible. The thing is, what exactly the possible is, even if you LLMs are responding back with the undesired response or a valid response, the main area of focus is data. LLMs are just treating your input, processing it, and the data where it resides, that is where your LLMs are taking as it is and responding back. So when we talk about human contextual, humor-based contextual language, it actually tried to learn whether humor responses can be made so that it will feel like human is responding back, not the actual AI. So that is data. So the reverse engineering is something can happen. You can fine-tune the LLM models. You can do that. But the problem is the data. So the fine-tuning of the model and fine-tuning of the data is both are required, not only one.
So it can help understand how it works theoretically.
Can you please repeat what?
So it can help how it works theoretically. Yes?
Correct. So just take a simple example. You have the LLM models. LLM models are utilized, they are responding you back based on the things which are available, based on the learning, intelligence, and the data, right? So if you do a simple, straightforward reversing the code and do a modification so that AI should respond back me with the accuracy, 100% accuracy, or whatever I am asking, it should respond. It should not disclose any other things. It is possible, but not 100%.
Thank you.
Давайте поаплодируем докладчикам.
Thank you.
Thank you.
Thank you, everyone.
Thank you.
Okay, thank you very much. Let's give a round of applause to the speakers. So guys, you need to choose now the question that you liked the most, and that person is going to get a little gift from us.
You listened and
Oh yeah, I guess there was a person. Yes, that was the model drift guy. He loves the drift, I guess. So that's the best question.
okay.
Yes.
Okay. Thank you very much. Congratulations.
Thank you very much for asking that.